Okay, so let's look at another circle example and how to use symmetry to get the coordinate of the other side of a diameter going through a circle. Now remember, this only applies with the diameter. It doesn't apply with another line that does not go through the circle. So let's keep in mind the following. With our previous explanation, the center was at the origin, and whatever we added from the origin horizontally, with the x coordinate, became the x coordinate. So 0 plus x is x. And the same with the y, 0 plus y became y. And those same magnitudes we subtracted from the origin, from the center, to get to the negative x and the negative y. So we're going to apply the exact same principle, but the only difference now is our center is not at the origin. Okay, in this example, the coordinate of point P is 4, 6, and the center is 1, 2. So let's keep the following in mind. For the x coordinate, to get from 1 to 4, we have to add 3 units, right? And to get from 2 to 6, we had to add 4 units. So whatever we had to add in the x, we are going to have to subtract to get to this coordinate. So we added 3, so we are going to subtract 3. So 1 minus 3 is negative 2. And whatever we added, 2 plus 4 became 6. Now we're going to say 2 minus 4, and that will become negative 2. So we still had symmetry, but our center was not at the origin. But this is an easy way to do the calculation if you have this type of setup. And yes, you can take the equation of this line and substitute it into the equation of the circle, but it will take very long to do that calculation. So if you spot this in a test, it's very quick to do the calculation in this way.